Okay. So we're okay when we see side angle side, you guys know to use law of cosines, correct? And then the other time we do law of cosines is when we have side, side, sides. That's what I'm going to do on the last example from 17.3. So 17.3 here, I'm going to clear the screen off. So down here we have side, side, side now. Okay, this homework at the bottom should be accurate. 3 through 15 odds, 16 through 18, and 22. You should be able to do all of those problems out of the textbook. Okay, so this, yeah.
Sorry, I was looking back at the law of sines notes, and one of the triangles was angle side, side angle side. But is that possible for law of sines? Because that's what's confusing me. Is I know that's you should use law of cosines for that, but it's also a part of our law of sines notes.
It doesn't say side angle side. Check it again. It says AAS or ASA.
Yeah.
Or
and then
SSA.
one of the examples. Oh, okay. I didn't see that one. Sorry.
Yeah. So law of sines would be the other cases. If it's not side angle side or side side side, then you would be able to do law of sines.
Okay. Thank you.
But oftentimes, like the one we just did, you can do law of sines immediately after you do law of cosines. Okay. So for this one, see how we're given 3 sides? You can't use SOHCAHTOA here because it's not a right triangle. So for this one, if you know 3 sides of a triangle and you want to solve for the missing angle, you have to start by doing law of cosines. And the reason it's called law of cosines is because it has cosine in it. Nothing too fancy. Okay, so for this one, it doesn't matter which angle you want to solve for first. I'll just solve for angle Q. So if I want to solve for angle Q, the side opposite Q is going to go by itself. So I'm going to do 12. Well, first, let me define the variables. So this would be little q, opposite big Q, little opposite big R, and little p opposite big P. So one way you could use law of cosines here is if we're solving for angle Q, you do little q squared all by itself. And it starts off like Pythagorean theorem. So you have p squared plus r squared. But then it takes a turn. It's no longer Pythagorean theorem because you subtract 2 times the product of the 2 variables you just wrote, p and r. And then you have to multiply that by cosine of the angle opposite the side that's by itself. So the side that's by itself is q. So I'm going to use a big Q here. So this is how you would use law of cosines. And again, it doesn't matter which angle you solve for first. You can solve for P or R first step if you want. Okay, so we know little q is 12 from the picture. We know little p is 13. We know little r is 9. So minus 2, we just said p is 13, r is 9. So my only variable here is angle q. So I'm going to write 12 squared is 144. Okay, when you do 13 squared plus 9 squared, let's figure out what that equals. It's going to be 250. So 13 squared plus 9 squared becomes 250. Minus, you do 2 times 13 times 9. That's going to be 234. So that came from multiplying these 3 numbers together. I got 234. Then I have cosine q. Common mistake students make is they do 250 minus 234. Please don't do that. Because if you have 250 minus 234x, you can't combine those. So same thing here. You keep it separate. You subtract 250 to both sides. So when you do 144 minus 50, That's going to give you negative 106. And I have negative 234 cosine of Q. So I just subtracted 250 from the left and the right side. And then cosine of Q. I divide both sides by negative 234. If you want to make this positive, that's fine. So to solve for Q, I'm going to take the inverse cosine of both sides. That's how you get rid of cosine, is you take the inverse cosine. So I take the inverse cosine of the left side, and then I also need to take the inverse cosine of the right side. You don't have to simplify this yet because it's not a final answer. But if you did simplify it, that's fine. And instead of just writing Q, the correct way to write that is the measure of angle Q. So the measure of angle Q is approximately, can everyone do this on your calculator? Find inverse cosine of 106 over 234.
$63.1.
63.1 is correct. Okay, so from here, so this was step one. I'm going to change colors. After we do law of cosines, the next step is usually to do law of sines. So now that I know one of my angles, I can use that angle. So sine of 63.1 over the side opposite angle Q is right here. It's 12. And then it doesn't matter if you want to solve for P or R next. I will just solve for R. So I have sine of R over the side that's opposite big R. Opposite big R is 9. So over 9. So this is what you did for part of Monday's homework. So you can cross multiply here. So we have 12 sine of R equals 9 sine of 63.1. And then sine R is going to equal 9 times sine of 63.1 divided by 12. So the last step to get R by itself is to take inverse sine of both sides. So you're going to do inverse sine of 9 sine of 63.1 over 12. Plug that into your calculator. That gives you the measure of angle R. So 9 inverse sine of 9 sine 63.1 divided by 12.
$55.6.
I don't think it's 55.6.
42.
I think it's 42. Maybe try it again on your calculator.
I got 41.9.
41.96 maybe? Or 41.9 is fine. If you have 41.9, that's okay. It depends on what step you rounded it.
We're not rounding it to the nearest whole number?
I'm just rounding to the nearest tenth. Maybe it was 40. 41.9. I'll check it. So second sine of 9, sine of 63.1 divided by 12. Yeah, I'll round that to 42. It's 41.97. So this was step 1. Step 2, and then step 3 should always be easy. If you want to find the third angle, all you have to do is subtract the other two angles from 180. So we're missing angle P. So measure of angle P equals 180 minus 63.1 minus 42. So plug that into your calculator. That'll be 74.9. So that's all I got for law of cosines. We still have one more one-page lesson of notes. But any questions on law of cosines?
Mr. Morrison.
Morrison? Oh, sorry.
Yes.
I found P. Wait, never mind.
Okay.
Mr. Morrison.
Yeah.
So would you know? So you wouldn't. So for law of cosines, would you ever use it on a right triangle?
You could, but it's usually easier if you're on a right triangle. You would just do Pythagorean theorem. It would be a lot faster. But it would work. It would still work for a right triangle. So good question.
Okay. Thank you.
Mm-hmm. Or instead of Pythagorean theorem, you could use SOHCAHTOA for a right triangle. So that's just easier. Okay, so anything else before we go to 18.0 notes? Okay, so I'm going to clear this out. So the homework is out of the textbook for this one. So all of this is going to be due on Monday, so April 6th. So that's still 5 days away. So you have 2 assignments due then. So the other assignment will be the worksheet from 18.0. So 18.0, it's called 18.0 because it's not actually a section in your textbook, but this is going to help you for Mod 18. So this is kind of like a precursor. It should be stuff I believe you saw in IM2. Can someone turn their mic on and say yes or no? Did you learn special right triangles in IM2?
We did.
Yeah.
Okay, so hopefully this is just a review of IM2, but it's stuff we're gonna need in Mod 18. Okay, so we're gonna be doing special right triangles. So there's 2 types of special right triangles. There's 30, 60, 90, and there's 45, 45, 90. Why they're special, a 30, 60, 90, that's half of an equilateral triangle. A 45, 45, 90, that's half of a square. So if you cut a square in half on the diagonal, you get a 45, 45, 90. If you cut an equilateral triangle in half, it makes a 30, 60, 90. Okay, so here, I'm gonna be abbreviating for this lesson. So I don't have to keep writing it, especially doing it on the iPad. I don't wanna write these words over and over again, it'll take too long. So every time I use a capital H, that's gonna stand for hypotenuse. So this is just kind of making my key at the top. So when I'm using capital H later, I'm talking about the hypotenuse. When I use a lowercase l, that's going to be the leg. When I use a lowercase s, that's going to refer to the short leg. And when I use a capital L, That's going to be the long leg. Okay, so everything I do in red is going to have to do with the 45, 45, 90. And everything I do in blue is going to have to do with a 30, 60, 90. So I'm going to start with red. So coming down here, first half the battle, you have to identify what type of triangle you're working with. So all of these down here, these are, except for this one is an exception. So that's an X. So these are all 45, 45, 90s. So there's only one formula you have to know for a 45, 45, 90. It's going to be this formula right here. Hypotenuse equals n times square root of 2. How I'm going to be writing that is h equals L for the leg, L times square root of 2. $30, 60, 90 has two different formulas. So I'm going to highlight these. So it's this formula and this formula. Then I'm going to write it out. So the long leg is always the short leg times radical 3. And the hypotenuse is always 2 times the short leg. So how do you know which is the short leg and which is the long leg? Well, first of all, how do you know what a leg is? So whenever I say a leg, so every right triangle has 2 legs. The 2 sides that are not the hypotenuse are your legs. So if you look over here, let me highlight here. So the short leg is always opposite the 30-degree angle. Oops. So short leg is opposite the 30. So that's why N is your short leg. So maybe I'll also call it S, little s. And the long leg is always opposite the 60-degree angle. So this is the long leg opposite the 60. And you guys know how to identify the hypotenuse. So please remember the 30-degree, the short leg is always opposite the 30-degree angle. The long leg is always opposite the 60-degree angle. Okay, so let me just write down here. So down here, these are all 30, 60, 90 triangles. So these are all 30, 60, 90s. You guys are so quiet. Everyone's still there?
Yeah.
I'm here, Mr.
Yes.
Morrison.
Okay,
Yes.
thank you. I guess you guys are just all following directions, having your
I
mics
mean,
off. But it's
it
okay
could
to
be
ask
louder.
questions.
It could be louder if I'm stay unmuted. I'm just saying.
Okay. If you have a question, you should be unmuted. I was just surprised. You just went along. You just have gone a while being muted. So I just wanted to make sure everyone's doing okay.
Well, I'm kind of sad though, Mr. Morrison. My
Why?
sister
Because we only
lost-
have 45 more minutes of math.
Well, yeah, and my sister lost my Harry Potter wand.
Oh, that's sad. Is that the sister that doesn't have milk with her cereal?
Yes.
Oh, it would be her, wouldn't it?
Ah,
That explains everything.
It does. Well, I'm glad the brother that I'm gonna have in 2 years, I'm glad he puts milk in his cereal.
Yeah, I was glad about that too.
All right, so I'm going to clear this out to do some examples at the bottom. Okay, so clearing this out here. Okay, so sticking with the colors, I'm going to start with red because this first one, hopefully you can tell, this first one is a 45, 45, 90. If the two angles are congruent for a right triangle, if it has two congruent angles, it has to be 45, 45, 90. No other way no other way around it. So right here, I'm going to call this side, these are my legs. So it has an L and an L. So the formula for a 45, 45, 90, you would say hypotenuse equals L times square root of 2. So if you're stuck, I would say first step, just write out the formula I'm giving you. This is the formula, the only formula you need to know for a 45, 45, 90. So you can just copy the formula. And now I'm just going to plug in for the hypotenuse. So this right here is my hypotenuse. So I plug that in for H. So it's 10 radical 2 equals L radical 2. So to solve for L, you just divide both sides by radical 2. So L equals 10. And we just solved for a 45, 45, 90, it's always isosceles. So we just solved for the two congruent sides. So this side has to be congruent to this side for a 45, 45, 90. So we just solve for the two congruent sides. Both those sides would be a length of 10. Okay, this next one I'm going to do in blue because it's a 30, 60, 90. So this is a 30. That means the side opposite 30, I'm going to call it S. And then the hypotenuse, I'll call it capital H. So when it's a 30, 60, 90, you have to remember two formulas. This is 30 degrees here. Okay, so the hypotenuse is going to be 2 times S. That's the first formula. The second formula, the long leg, is going to be the short leg times radical 3. This is true for all 30, 60, 90 triangles. So you have to know these formulas because you're usually just given one side, so you won't be able to do Pythagorean theorem. Okay. So let's see, the hypotenuse is 2s. I can't plug anything into the first equation yet, so I'm going to use the second equation. So my long leg right here is 5 radical 3. So when I solve for s, I divide both sides by radical 3. So s equals 5. So that's my first answer. And to find the hypotenuse, I can just plug that back into this equation. So the hypotenuse is always double the short leg. So 2 times 5, this hypotenuse of 10. It's doing okay. I should check. Still see a lot of people
Yes,
without their
sir.
videos on.
Yes.
Yes, it's easy. It's a reminder, Mr. Morrison.
It's a reminder because you know
We're
this
Gucci.
already. Okay, it's good to be Gucci. Okay, I'm glad Jeffrey still has not gotten eaten by the dinosaur. Okay, so coming over here, the hypotenuse is 2s. And so this one's a 30, 60, 90. So this is 60 degrees now. So the long leg is always s times radical 3. So this is the hypotenuse. This is the long leg. And down here, this is the short leg. It's supposed to say S, but it doesn't look like an S. All right, so this one I know the hypotenuse, so I'm going to plug into the first formula this time, first step. So 14 radical 2 equals 2s. So when you divide both sides by 2, you're going to get s equals 7 radical 2. And then you can take that, plug it in for s to find your long leg. So it's going to be L equals 7 radical 2 times square root of 3. So this simplifies to 7 radical 6. Okay, for this next one, this is your 45, 45, 90. So I'm going to go back to red. So that means it just has 2 legs. You don't have a short leg and a long leg because both legs are the same length for a 45, 45, 90. So once you solve for one of the sides, you solve for both. You're staying with us, Madison? Can you hear me, Madison?
Sorry, I was muted, but yes.
You were distracted.
No, wasn't.
Okay.
I was biting my nail.
Okay. H equals L radical 2. So here the hypotenuse is 10. So L is going to equal 10 over radical 2. You guys remember learning not to leave a radical in the denominator? So when you have a radical in the denominator, you can times the top and the bottom by that radical. So this is going to be 10 radical 2 over 2. And this simplifies to 5 radical 2. Okay. This next one I'm going to do quick. Here, this one should be easy. This is a 45, 45, 90 when it's isosceles right triangle. So H equals L radical 2. You just plug 5.7 in for L and you're done. So 5.7 radical 2, and this is in inches. Did someone tell me what kind of special right triangle the next one is?
30, 60, 90?
30, 60, 90. Because for this one, I'm going to do blue. A plus 2A has to equal 90 because it's a right triangle, so the two acute angles have to add up to 90. So then 3A equals 90. So that means A equals 30. So if this angle is 30, this one is 2 times 30, which is 60. So from here, it becomes the same problem as this one. So you get the same 2 answers. Same, I'll say same as above. You just have to identify that it's a 30, 60, 90 right triangle. So you know which formulas to use. Okay, so the next one is yes or no. Does it form a 45, 45, 90? Well, let's see. We need to know if it does, then H has to equal L times radical 2. So H is always going to be the, so someone tell me which value is bigger, square root 6 or 2 radical 3?
2 radical 3 is bigger.
2 radical 3 is bigger, thank you. Ethan, is your screen doing okay? Are you there, Ethan? Did Ethan go away?
Yeah, I am. Sorry. I'm here.
Okay. All right. So 2 radical 3 equals L would be square root of 6 times square root of 2. So this would equal square root of 12, which equals 4 times 3. And the square root of 4 is 2. So doesn't the hypotenuse equal L times the square root of 2?
Yes.
So here I would say yes, because we were able to show the left side equals the right side. So as long as you can say that the longest side is square root of 2 times the short leg of the congruent sides, or times one of the legs, you know it's yes. For the next one, H would have to equal 2S because it's a 30, 60, 90. So the longest side is 10 radical 3. Is that the same as 2 times 5, the short leg? Is 10 radical 3 equal to 10?
No.
No.
No. So this one, we got some false statement. So this one would be no. Those could not be the sides of a 30, 60, 90 triangle. All right, so we just have 2 more to do today. We're almost done. Any questions so far? Okay, so I'm going to clear this out. Okay, last 2. These are fun problems.
Bless you. Bless you. Thank you.
Okay, so for this one here, again, I said earlier the reason it's a special right triangle, 45, 45, 90 is half of a square. So the diagonal is this side here, so it's 18. So find the perimeter and area of this square. So this is a good like SAT type question. So if you know the diagonal is 18, because it's a square, it was 90 degrees. When you cut it in half with a bisector, it's 45 degrees. So this is a 45, 45, 90 special right triangle. So I can use my formula. I meant to do this in red. I guess I'll switch now. Okay, so the hypotenuse is going to be the leg times square root of 2. So the hypotenuse of this triangle is 18. And this is L. So it's going to be L times square root of 2. So to solve for L, I'm going to divide both sides by square root of 2. So I'm going to times the top and the bottom by square root of 2 to simplify this. It's going to make the number, could make it easier to work with, possibly. So you get 18 radical 2 over 2, and this simplifies to 9 radical 2. So the perimeter of this square, if you do L plus L plus L plus L, the perimeter would just be 4L. And the area is just going to be L squared. You just take your side length and square it. That's the area. We just found the leg of the right triangle is the same as the side length of the square. So right here, this is going to be 4 times 9 radical 2. So that simplifies to 36 radical 2. So that's going to be your perimeter. And then you take L, which is 9 radical 2, and you square it. Be careful with squaring this because you have to square the 9 and the radical. So when you square the 9, you get 81. When you square the radical, you get 2. So this is going to give you 162. And this should actually be in square inches. This one up here would be in inches. So any questions on this one?
Mr. Morrison, the long leg is
Yeah.
the height of the triangle, right?
Yes, it's also well, there's no long or short leg for a 45, 45, 90. Both legs are the same.
Okay.
So the height
Well, what about
and the
for
base would be the
60?
same. So 30, 60, 90, the short leg is
Wait, I didn't
opposite
hear
the
you.
30. The long leg is always opposite this. For a 30, 60, 90, the short leg is always opposite the 30-degree angle. The long leg is opposite the 60-degree angle.
Yeah. Oh, gotcha.
Okay, so we'll look at that on the next one. So I'm going to clear this off now. You're able to mute yourself, Ethan? Thank you. That helps. All right. So for the equilateral triangle here, so hopefully everyone knows from equilateral triangle, all three angles are 60 degrees. But when you cut a 60-degree angle in half, then it's going to become 30 degrees. So this becomes a 30-degree angle. The one down here wasn't cut in half, so it's still 60 degrees. So this is going to be your short leg. This is your long leg. This is your hypotenuse. So the long leg represents the height of the triangle. So we know it has a side length of x. So if it has a side length of x, that means the hypotenuse would be x. This right here would be half of the hypotenuse, which is x over 2. It's half of the entire big triangle. So I'm going to use my formula, my two formulas here. So my first formula is h equals 2s. And my long leg is s radical 3. But I'm going to do everything in terms of x. So the hypotenuse is x equals 2s. Well, we already got this one, but I'll just write it again. So s equals x over 2.
Mr. Morrison, is that 25 or 2s?
2s.
Okay, thank you.
Okay, so for the next one, I'm going to take this and plug it in here. So the long leg is going to be x over, I'm sorry, yeah, it's going to be x over 2 times square root of 3. So this is my long leg. So the question is saying find the area. So the area of any triangle is 1/2 base times height. So this is going to be 1/2 times the base. Well, the base would be this entire side here, which is just x. If you want to find the height, the height is the same as L. So we just solved for L. L was x over 2 radical 3. So this is actually a problem from last night's homework, or a couple nights, or Monday night's homework, which was due today. So if you want to find the area of an equilateral triangle, you can also use it, or you can find it using special right triangles. So it's going to equal, when you simplify this, you can put x over 1 square root of 3 over 1. So when you multiply all the numerators, 1 times x is x squared, and then you have radical 3 in the numerator. When you multiply all the denominators, you get 2 times 1 times 2 times 1. That'll give you 4. So the area of an equilateral triangle is the side length squared times radical 3 over 4. So hopefully that looks familiar from 17.2 homework. So that's probably a good formula to remember. If you have an equilateral triangle, to find the area, just take the side length, square it, times it by radical 3, and divide by 4.